Okay friends, so let's continue our presentation about decision support systems. Now what I was trying to accomplish in the first part of this presentation, I was trying to show you that we humans, we have one weakness. And that weakness is that we often make wrong or flawed or suboptimal judgments or decisions. And the reason we make those wrong or flawed judgments or decisions is that oftentimes we lack reliable information about objects, about people, about organizations, about organizational phenomena, and so forth. Now, in the absence of reliable data, reliable information, we apply some kind of heuristic, some kind of mental model. And I told you that those mental models that we have for making judgments about people, about events, about organizations, they're also not perfect. They're not perfect because they're subject, they're impacted by a number of cognitive or mental biases that have been well documented by researchers in psychology. So we talked about some of those mental biases. And also I told you that that list is by no means exhaustive. There are so many other biases that we haven't touched upon. So if you have time, just Google cognitive biases and you'll see a Wikipedia article that has probably dozens, if not hundreds, of those mental biases discussed. Now, within an organization, the situation with the absence of reliable data or information is often made worse by the fact that there's just too much information. I mean, nowadays many organizations, many companies, many businesses, they have thousands of employees. They have thousands of managerial levels, at the operational level, tactical or middle level, and senior level. So there are so many employees and there is so much information. A lot of that information is not reliable. So senior executives or even middle managers, meaning people who are supervising, by middle managers we mean employees who are supervising operational or field employees. And by senior management we mean the ones who are typically at the C level. We are talking about vice president, CEO. They're just swamped with all kinds of information being channeled to them from the bottom of the organization. So there's just a lot of information out there, and research by somebody named Herbert Simon. Herbert Simon, he is a Nobel Prize winning American economist. His research showed that we humans, we have the so-called bounded rationality. Now, what we mean by bounded rationality is that actually we mean a lot of things, but one of the things that Herbert Simon meant by that was that we have limited brain capacity to process information. If you ever took psychology class, you were probably exposed to this idea that we humans, we can keep something like between 3 and 5 bits or chunks of data in our short-term memory. So for example, when I give you 3 numbers, let's say 1, 3, and 4, you can keep those 3 numbers in your head and you can write them down, okay? However, if I give you 7 numbers, let's say 1, 2, 5, 7, 3, 7, 5, something like that, then you may have problems keeping it in your short-term memory and writing it down. So that's why when people write down phone numbers, they usually separate phone numbers into 3-digit combinations because they know that we can only keep 3 digits at a time in our head. Okay, so we humans, we have bounded rationality, and there's a lot of information coming our way if we're somewhere here, at the level of middle management or senior management. So this makes decisions even more difficult. Not only you are not sure in truthfulness or reliability of information or data that is coming your way, there's also so much data, so much information, managers are often overwhelmed with that. And that makes it hard for them to make those decisions that are appropriate for their level. Now, when managers or employees make decisions, typically they fall into 3 categories. We have structured decisions, we have unstructured decisions, and we have semi-structured decisions. Now, structured decisions, they are so-called programmable or programmed decisions. So basically this means that those decisions are typically routine, they happen all the time, they are made all the time, and there are usually specific policies, procedures, or actions that can be identified to help make the decision. So this is how we usually solve this type of problem, for example. Now the key here is that the key demarcation principle here is that if it's a structured decision, typically you can write code, you can instruct computers on making those decisions. For example, if stock price of a particular company falls below $100 per share, then sell that stock. Now, this is something that you can train a computer to do. So those are the structured decisions. They can be structured and formalized in the form of some kind of policy, manual, or computer code. But there are also the so-called unstructured decisions. Now, unstructured decisions, they are fuzzy decisions. There are decision scenarios that often involve new or unique problems that haven't been encountered before. And individuals typically have little or no programmatic or routine procedure for addressing those problems or making decisions. In other words, there's no manual on how to address those problems or how to make those decisions. So basically, the keyword here is fuzzy. Those kind of scenarios, those kind of problems, they're very fuzzy. It's kind of hard to understand what is happening there, and it's even harder to understand what needs to be done. Okay, an example of a fuzzy decision or unstructured decision would be something like this. What kind of product line do we pursue to be competitive in our industry, right? What kind of businesses do we discontinue to optimize our cost structure, right? Now, those kind of decisions, they require some kind of creativity, some kind of human judgment, and human judgment, is weak in a way that it's not as good when it comes to dealing with numbers, especially, high volume of numerical or textual information. This is something that computers are good at. So humans are not good with those structured, high volume data, but humans are usually very good when it comes to unstructured decisions. So for example, humans, they can sit down and can write a good song or come up with a great strategy or come up with a new product, something that computers cannot do. But again, things are changing, and nowadays, a lot of researchers, a lot of thinkers in the field of computing believe that computers are increasingly becoming good at unstructured decisions. For example, Amazon is becoming good at figuring out what kind of books you're looking for, what kind of products you're shopping for. Google sometimes know exactly what you're looking for even before you type the entire query, in Google's search engine. There's a great book on this subject. If you ever have a chance, I suggest you read it. I'll show you right here. It's a book by Eric Brynjolfsson. I always forget how to pronounce his name. So read this book if you have a chance. It talks about the second machine age. Basically, what the authors are arguing in this book is that computing is becoming so cheap, so powerful, so accessible, so sophisticated that even tasks that have been traditionally considered to be unstructured are increasingly being done by computers. For example, translation. Translation used to be like somewhat of a joke among programmers, among developers, because it has been notoriously bad in translating one language into another. We had all those funny translations and funny situations where the translated text has nothing to do with the original meaning of the text. But one powerful example that Eric and his co-author use throughout the book is Google's project on creating cars that can navigate across in cities without a driver. So those cars, they use a combination of GPS sensors and all kinds of different sensors to navigate around big cities such as San Francisco. And Google has been very good with it. I remember the latest data was something like their cars have traveled 90,000 miles around San Francisco Bay Area, and I think there was only one single accident involved that those cars were involved in. But that accident happened actually when one of the cars was piloted by a human being. Well, speaking about human pilots, Google representatives, they make sure that there is a person sitting inside a car. Now, that person is not steering that car. The reason they put a human being inside their automated cars is that they don't want people on the street to freak out, because they told the public that in the past, whenever somebody sees a car just driving around without any driver, people freak out and they start calling police and they feel scared. So that's why they put a human inside every car. Although that human is not steering that car, is not intervening with the operations of that car. So computers are becoming increasingly good at making unstructured decisions. The kind of message that Eric Brynjolfsson and his co-author are sending to the young generation is that the future that awaits for them is not very bright in terms of employment, because a lot of the professions which people thought will never be automated with the help of computers are now getting automated. But again, I don't, it's hard to predict future. I wouldn't put too much confidence in those long-term predictions, regardless of who is making those predictions. Because usually by the time this kind of gloomy scenario approaches, humans figure out something else to do, right? So maybe there will be less demand for truck drivers, I don't know, for teachers, because all pedagogical processes will be automated with the help of technology. But there may be more demand, I don't know, maybe for nurses or maybe for musicians, who knows? So I wouldn't worry much about that. And then you have semi-structured decisions. Those are decisions that are somewhere in between. In other words, there is a component to that situation that can be structured, that can be automated with some kind of computer instructions, like some kind of script or some kind of software application. And there is also a component that cannot be automated, cannot be captured with some kind of manual, policy, or computer code. For example, evaluating companies, financial performance of companies is probably something along the lines of semi-structured decision making, because some aspects of the decision can be automated. For example, computers, enterprise systems, accounting information systems nowadays, they can generate all kinds of financial reports. However, a manager still needs to look at those reports to make a judgment about the current financial health of a company and the future that awaits for that company, financially. Because as you may know, accounting performance, the kind of numbers that companies sometimes report in their balance sheets are not necessarily indicators of real value that companies are delivering to their shareholders. So some decision scenarios are semi-structured. Now, decisions are made by individuals, by teams or groups, or by organizations, and all those decision makers, or types of decision makers, they bring their own knowledge and experience, and they also bring their own biases, their own flawed mental models to decision making. And therefore, because every individual, every group, every organization has a unique experience, unique knowledge, unique biases, then everybody's approach to decision making is different. However, there are several stages that seem to be found across all approaches or many approaches to decision making. And by the way, if I'm not mistaken, those stages, they actually come from research by Herbert Simon, that Nobel Prize winning economist who discovered bounded rationality. So decision making often starts with intelligence. Intelligence means when you have some kind of situation in front of you, you do some research, you do some background research to understand better what the problem is or what kind of course of action needs to be undertaken. So once you do some background research, you enter the design stage. Now, design stage involves brainstorming about possible solutions. Okay, so basically, whenever you have a problem, there is always more than one way to solve it usually. So once you identify all those different approaches to solving that particular problem, you engage into choice. Choice means you start evaluating different alternatives to select the best one, to select the best solution to a problem. Then you actually decide which alternative you will take, what kind of solution you will actually select for your given problem, and then you go ahead and implement the solution. Now this framework, this sequence of steps, since the time Herbert Simon formulated those steps, has been extended. One step that has been added frequently is the so-called feedback loop. Once you implement a particular solution to a problem, or once you implement a particular decision, then you need to kind of go back and see whether your problem has actually been addressed. If it hasn't been addressed, then you need to go through this cycle again to create a new solution, or make a new decision. Now, there are many generic strategies for making decisions. I'm familiar with some of them, but not all of them. There's the so-called optimization approach. Optimization approach means you're trying to optimize the most important variables or the most important outcome in a particular decision-making scenario. For example, as a student, you may have several things on your plate. For example, you're taking courses, you're enrolled in several courses because you need to get a degree. At the same time, you may be working. The third thing that you may have on your plate is that you have some family commitments, or you have social life, you have friends, you have events to attend. So the question becomes, how do you optimize those things so that you achieve like the maximum or the most optimal, the most desirable outcome? For example, how much time do you spend studying? Because if you spend too much time studying, then in your situation you may sacrifice your social life, or you may even get fired from your job. If you study too little, then you may fail some of your courses or all of your courses, and then you will compromise your educational career, right? So optimizing means what is the optimal time of studying, relaxing, hanging out with friends, working, and spending time with family, so that overall your well-being, your happiness is optimized. Satisficing is another approach to decision making. It basically means doing job that is good enough in all important areas. So satisficing means like you're not deciding on the optimal amount of time you will spend studying, working, and attending social events. You just make sure that you study so that you pass all of your courses, that you meet with your friends once in a while, and then you devote your time to family, once in a while. So satisficing means just good enough, just trying to be to kind of get by. Elimination by aspects is another approach to decision making. It basically means that you have certain criteria. For example, let's say you're looking to buy a car, and you may formulate certain criteria towards that car. For example, you can say that, well, I only want to have a white car, so that will eliminate a lot of cars that are available for sale, let's say here in the Murray region. Then you may say, well, the kind of car that I'm looking as an SUV. So again, that criteria will eliminate a lot of cars from your list. So eventually you will narrow your choice to one or maybe a few cars. Incrementalism means you go with the past figures first, and then you do some kind of incremental changes to those past figures. This approach is frequently used in budgeting. For example, last year budget, let's say the amount of money devoted to building renovations, we'll take last year budget and then let's say we'll add 5% to it, depending on our financial health as an organization. Now, mixed scanning, I think it's a bit of complicated procedure, and to be honest, I'm not familiar with it. But mixed scanning involves a number of quantitative approaches and qualitative approaches to gathering and analyzing information for making decisions. So it's like a hybrid approach between quantitative, numerical, analytical, and qualitative or intuitive approach on the other hand. Then there is also analytical hierarchy process, or AHP. I think it's a very trending approach to decision making nowadays. Basically, under this approach, you formulate certain factors that are important for your final outcome, and you give each factor a weight, and then you evaluate alternative decisions, alternative candidates in your scenario. In accordance with those levels, with those criteria, and you adjust ranking of each potential candidate within those domains by a specific weight. So basically, let's say you're trying to hire a CEO, chief executive officer, and then you specify the kind of criteria, the kind of traits you're looking for in your future leader. So, for example, leadership skills, innovation capabilities, and people skills, right? And you will say leadership skills are the most important skills. They get a weight of 0.5. Then innovation skills will get a weight of 0.25. And then people skills will get a weight of 0.25 as well, right? So then you rank each candidate according to those criteria, and then you adjust the ranking by the weight, and then you come up with some kind of final score for each of those candidates that you're considering for the CEO position. And then, based on that, you decide who will actually get hired as a CEO or chief executive officer. Now, the kind of decision models that are used in decision support systems or by decision makers, they fall into 4 categories. First of all, you have the so-called deterministic models. So basically, it involves some kind of linear programming. Okay, so basically you decide, well, if this is true, then do this. So this is something that can be translated in linear code. For example, if somebody's income is above X, then make this person, qualify this person for a loan at our bank, right? So we humans, we understand those models really well. We can understand those if-then rules and scenarios. Now, there's another approach. It's called stochastic approach or probability-based approach. Now, this is something that we humans are not good at. I mean, we often don't understand probability theory and probabilistic reasoning in daily life. And of course, there are all kinds of cognitive biases here. For example, humans, they tend to overestimate probability of a negative outcome, and they tend to they may underestimate probability of a positive outcome. So basically, most people, they're risk averse. Okay, so they would rather have a 0 chance of a negative event rather than have like a small chance of a negative event and then a high chance of a positive event. Let's say some kind of positive outcome in their career. So we humans, we're not good at understanding statistics. Another typical example of humans being ignorant when it comes to statistics is fear of sharks, right? A lot of people, when they go to the beach in Florida, they are scared. They're scared that a shark will bite them. However, statistically speaking, you are much more likely to die in a car crash on the way to the beach than to die from a shark attack, right? So we don't understand that, and we see those images of sharks. Most likely those images, they originated from that movie Jaws, I believe, right? So we're scared of sharks, and we want to minimize the amount of time we spend in the water. And when we drive our car, we don't even think about it. I mean, we don't think about dying. We feel, in fact, a lot of people feel good when they drive. Then there is also simulation approach. Simulation means you kind of allow, let's say, a computer to generate different scenarios, different things that can happen in the future. Okay. Now, this seems to be a very realistic approach because nobody can predict future. I mean, we never know for sure what will happen in the future. However, you can brainstorm about possible scenarios, things that may happen in the future. And giving this collection of scenarios, you may ask yourself as an individual or as an organization the following question: are we prepared for those possible scenarios? And then there are all those domain-specific decision models, something related to weather, to oil exploration, to finance, to economics. So they have very specific models. For example, Martin Scholl's formula for evaluating real options, for evaluating future options. So this is his model that he proposed for that kind of domain. Now, the thing about those formal theoretical conceptual models is that formal approaches, rigorous approaches, conceptual approaches, theoretical approaches are not always possible in decision making because many important problems are completely new, and therefore executives, they basically rely on their past experience, on their knowledge, on their expertise, and whatever, random other variables that come into play when they make decisions. And that approach, the so-called ad hoc approach, is called the garbage can approach. So the garbage can approach means that executives, they make decisions oftentimes on that ad hoc basis. A lot of things come into play, their emotional well-being, their intuition, their knowledge, their prior experience, how they feel about the company. Do they feel optimistic, pessimistic? So based on all those things, in that particular context, they make a particular decision. And then it becomes kind of easy to judge them and to laugh at them. Because, as Warren Buffett says, things are always clear, when you look back, but they're not very clear when you look forward, right? So, because executives make those ad hoc decisions, in a way they make right decisions for that specific context, for that specific time. But those decisions may not be optimal, may not be good, in the long run, though. One second. So how can IT be used, how can information technology be used to support decision makers? Well, in a number of ways. First of all, information technology can help team members to communicate and collaborate on decision making. For example, there can be like some kind of online collaboration tool where board members decide on a particular budget item. Also, information technology can be quite useful in that situation of information overload. Information technology can be quite useful for assimilating, aggregating and filtering data for senior decision makers. Also, IT can assist in problem recognition. Computers can be automated, can be programmed to search through huge data sets and detect certain patterns. Let's say patterns in relation to health. And then based on those patterns, they can make some predictions about future problems that may happen with a particular patient. Also, computers are good at problem solving. Again, problem solving involving structured decision making or structured problems. And then also computers can be good at putting the results together into coherent or cohesive package. Let's say through some kind of visualization, through charts, pie charts, bar charts, and so forth. Now, one comment here to make, I don't want to get too philosophical here and talk about the distinction between data, information, and knowledge, so I'll be very brief here. Now, what people typically mean by data, they mean this raw input, something that is coming from some kind of transaction processing system. Now, once data is collected, once it's stored in a database, then you can apply certain processing rules to this data to come up with information. Now, by information, people typically mean process data. This data that is being processed or aggregated and put into a format that can be understood by humans. Because when you're looking at a huge transaction database, let's say involving purchases at the supermarket, you may not make much sense out of it as a human, right? However, when you summarize those transactions by categories, let's say groceries, clothing, medicine, all those categories, then you can make some judgments. You can say, well, it looks like in our store the biggest sales item is food, so we may want to specialize in selling groceries. So this is information, and then information, it's useless. It doesn't have any value unless it is put to practice, unless this information is acted upon. And this is what researchers typically mean by knowledge. Knowledge means some kind of information that can be acted upon, that can be put to practice. Okay? And there are all types of knowledge. I don't want to get into that, but you need to understand that information is different from knowledge, right? Knowing what, which is information, is different from being able to do something with this information, which is knowing how, right? For example, just because somebody knows a lot about football, because this person is watching a lot of football on TV, because this person is playing football, online, that person is involved with some kind of video gaming community related to football, does not mean that this person knows how to play football. So knowing about football is not the same as knowing how to play football, right? So the trick here is that decision support systems, they often give you information, but they don't give you knowledge. They don't force you to act upon that information. And that's why, when you look at job descriptions for data analysts, data scientists, you will see that influencing skills, political skills, people skills are very important for a job for data scientists or data analysts, because in addition to generating information, meaning reports that summarize data in quantitative or visual form, you also need to be able to persuade executives to act upon that knowledge. Okay, so information, which is usually the output of decision support system, is not the same as knowledge. Now, there are a lot of knowledge management tools out there, or information management tools, because some philosophers, I guess, would disagree that whatever you're capturing with forms, is knowledge. It's more like information. But nevertheless, there are forms for getting text in, for getting text out from a system. There are databases for storing this data. There are reporting tools for creating reports and visualizations. There is also analytical logic or models being embedded in spreadsheets, such as solvers, interactive charts. Also, knowledge management tools, they allow you to do some kind of programming so that you can automate data processing, data visualization, and also to store certain rules or triggers in a database. Now, there are different types of information systems that seem to be related to decision making. There are the so-called transaction processing systems. So those systems, they basically capture and store data. For example, you can have a transaction processing system capturing student registration information for every semester. Now, management information systems, they are one level above transaction processing systems. Management information systems, they typically aggregate raw data generated or captured by TPS or transaction processing systems. So they aggregate this data in report and they generate reports useful for middle managers. Decision support systems typically take things one way beyond that. Not only they generate information, they also allow you or help you make decisions, based on this information. So, for example, a transaction processing system can capture student registrations. Then management support system or management information system, MIS, will generate enrollment reports in different colleges, different sections. And then a decision support system will help, let's say, a department chair to make decisions based on that. So they will say, well, giving enrollment in the following computer science sections, next semester we need to open more of those sections. And then you have executive information systems. Typically, those systems provide high-level information to executives about their internal operations and also external environment. And typically those executive information systems, they're like executive dashboards, like high-level visualizations as to what's happening inside organization and outside an organization. Now, when it comes to the architecture, a typical decision support system can be viewed as follows. First of all, you have this database component. And this database component stores internal transactional data, and this internal transactional data can come from finance, from production, from marketing, from HR, and other departments within the organization. Now, this internal transactional data can also be combined with external data because, as an organization, you cannot kind of ignore your external environment. I mean, you're competing within a particular industry. The trends that are happening in the external environment, they're impacting your operations, so you may want to blend or mix or supplement your internal data with external data. And then you have a model base, so where you have strategic model, tactical models, operational models, and model building blocks and tools. So basically, this is the logic. So giving that data, you can apply certain analytical models to this data, right? And then you have some kind of user interface that links the two together, so that data is used in some statistical model, right, to produce some kind of outcome or decision. And then you have a decision maker, let's say an individual or employee or senior manager, accessing both of those database and model-based components using some kind of interface. Now, in this class, our database component will be implemented with the help of Microsoft Access, application. And then our model base will be implemented with the help of Excel, Microsoft Excel application. So how do decision support systems benefit decision makers? First of all, they supplement decision maker. Like for semi-structured decisions, they provide some quantitative and qualitative information, but then it's up to the decision maker which actual decision to choose. They also allow for improved intelligence, decision and choice activities. In other words, they help you do some research, aggregate data. They help you decide what is the what are the available alternatives, and then they help you select the best alternative. Also, decision support systems, they can facilitate problem solving. Again, if it's some kind of structured problem, then computers are usually very good at crunching numbers and coming up with possible solutions. But also, as I told you before, computers are increasingly becoming helpful with non-structured decision making as well. For example, analyzing text. Now, I took a course on text mining, and I remember, when they were demonstrating all those latest algorithms on text mining, and it's amazing how inaccurate those algorithms are and how much humans are better at doing those things. For example, they will take a huge chunk of text, and then they will apply all kinds of topic mining algorithms so that the computer kind of summarize the text by discovering the major themes or topic within that text. And a lot of the times those topics, they're not very representative of that text, because computers, they're not good at detecting hidden meanings, reading between the lines, analogies, allegories, and all those things. Now, for humans, it typically sometimes may take like just a minute to glance through that text and to determine what are the major themes or topics of that text. And overall, decision support systems can assist with knowledge management, capturing knowledge, storing knowledge, distributing knowledge, putting that knowledge to some kind of practical use. Now, specific DSS technologies, I wouldn't call them DSS technologies. They are more like categories of systems. Involve expert systems, where decision support systems, they act as an expert. For example, loan application system. People submit their information, and then the system will decide, as a loan expert, it will decide whether this person is pre-qualified or not qualified for a loan. Then you have executive information systems that again provide high-level information and allow executives to make high-level strategic choices as to where the company will go in the future with its product lines. Then you have management support systems. Those decision support systems help middle managers make decisions. There are also communication support systems or collaboration support systems that help individuals to collaborate on making decisions. And there are personal support systems, the systems that help you with personal decision making. One of those examples of decision support systems that I posted to Canvas is Mint.com, and Mint.com helps you manage your own personal finance and make decisions about your own, spending limits, your own budgets and so forth. So that would be an example of a personal support system. Now, one last comment I would like to make is that whenever you use a decision support system, you are not exempt from cognitive biases that seem to be like specific to decision support system. For example, information bias. People like to seek information even when they know that this information cannot affect action. For example, you know that as an organization you don't have money for upgrading a building. However, you keep researching and gathering information, and you know that this information is useless because you simply don't have money to invest into new building, regardless of what the building is like and regardless of how it's done. You just don't have money for it, so there is no point in dwelling in this information. Now, at the individual level, to be something like this, you know that you don't have money to buy a Mercedes, but you keep researching about different Mercedes models, different pricing levels and so forth. And then the most dangerous one, illusion of control. Illusion of control means the tendency to overestimate one's degree of influence over other external events. Some people, and sometimes those people are very smart, they think that they know so much that they can predict future. Now, sometimes they can, but sometimes they cannot. As Warren Buffett says, during a stock market crash, people who suffer the most are the ones who knew nothing about stock market and the ones who knew everything about the stock market. And read about a company called Long-Term Capital Management. That was a hedge fund, I believe, managed by 3 Nobel Prize-winning economists, including Martin Scholes. They used very sophisticated computer-based statistical models, stochastic models, to predict future stock prices. And they were quite successful for the first 3 years or so. I think for the first 3 years, they were averaging 40% return per year. So investors were very happy with this return. On the 4th year, they blew everything. They lost all the money that they had, to the point where the US government had to step in and rescue that fund because they were afraid that the entire financial system will collapse, right? So those people, and Warren Buffett uses them as an example, they were very smart. Their average IQ was probably the highest that you would ever get for people sitting in one room. Collectively, they had like 100 years of experience in the investments industry. And that's something that made them vulnerable because they had this illusion of control. They had this illusion that they can control future external events, and that's something that is beyond anybody's control. Most specifically, what happened with their fund is that they were investing heavily in China, Brazil, and Russia. And then, if you remember, there was this Asian financial crisis in late 1990s that brought down Russian stock market and Brazilian stock market as well. So basically, Russia and Brazil, they defaulted on their government bonds, and this fund, long-term capital management fund managed by Martin Scholes, was actually heavily invested in those government bonds. So that's how the whole fund disappeared in a matter of weeks. So don't think that just because you have a decision support systems, you can control external events and you can predict future and you can never make a wrong decision. So that's all for part 2 of my presentation devoted to decision support systems. Thanks for listening.